In this illustration, we'll discuss about a cylinder completing the rotation. Here the figure shows a freely suspended horizontal cylinder of mass m and radius r, which is free to rotate about its horizontal axis, and a particle of mass small m falling tangentially to cylinder as shown, and it sticks to cylinder at its surface at the midpoint. We are required to find the speed of particle before hitting, so that after hit cylinder will be able to complete the rotational motion about its axis. So in this situation here we can calculate the angular speed of cylinder just after hit by using angular momentum conservation. So here we can write by angular momentum conservation, we can write if initial speed of this particle at the time of hit is u, we can also write if particle hits the cylinder at a speed u, then we can write the initial angular momentum of this particle is mur, that is before hit, and after hitting as it sticks to the cylinder, its moment of inertia will be mr square for the particle and half capital M capital R square for the cylinder multiplied by omega, if omega is the angular speed of cylinder after particle sticks to it, which gives us the value of omega, that is mu divided by, this is, we can calculate and simplify, this gives us 2mu divided by 2m plus capital M multiplied by r, as one r gets cancelled out over here. So this is the value of angular speed we are getting after the particle hits the cylinder. Now this value of omega should be such that during rotation this particle will be able to reach the topmost point. Then only we can say that it will complete the rotation. If before this particle completes 270-degree rotation and the cylinder comes to rest, then it will come back rather than completing the rotation. So we can write to complete the rotational motion of cylinder, omega should be such that small m will be able to reach topmost point. Thus, by work energy theorem, we have, in this situation we can write that initial kinetic energy of the system is half, its moment of inertia is mr square plus half capital mr square multiplied by omega square, and this should be equals to, as the cylinder center of mass remain at rest at its axis, this mass rotate by an angle 270 degree. So we write it equals to mgr, or we can also write minus mgr is equals to 0. So this is the work done by gravity against gravity, due to which the whole kinetic energy is transformed to the gravitational potential energy of this particle when it reaches the top. Afterwards it falls down and it completes the rotation. So in this situation, if we substitute the value of omega over here, you can see this is giving us twice of m plus capital M multiplied by r square by 4 multiplied by omega square here is 2mu whole square divided by 2m plus capital M whole square r square is equals to mgr. In this expression, this r square gets cancelled out and here 4 also gets cancelled out. So simplifying this, we get the value of u. So here the value of u would be, in this equation, it gives us under the root of gr multiplied by 2m plus capital M divided by small m. That is the result of this problem.